Good morning. Welcome to the Alabama Aquarium at the Dauphin Island Sea Lab and to our Boardwalk Talks program. This morning we are going to chat with PhD student, Chris, if you could step forward just a little bit, Chris Gerber from Auburn, and he's in the engineering department at Auburn. So it's a little bit different perspective from what we usually hear from most of our students would be, and our faculty would be more of a biology or ecology or natural science perspective. So it's a little different to hear about coastal flooding from an engineering perspective and some of the impacts to coastal residents from coastal flooding, and then maybe some of the engineering solutions for coastal flooding. And so one of the products that can help managers plan is maps. So there are products that can anticipate how low-lying areas, because they can be elevation maps, can predict how these areas will flood with X amount of water flooding into an area. So I'm going to let Chris tell you a little bit about what the engineering perspective is, and also specifically what he's working on. So with that, I'll let Chris tell you about it.
Great. Well, thank you guys for having me. So as she said, I'm not in marine biology or ecology. I'm a civil engineer, not even really in the environmental side of things, but the program that I'm working with is actually through Mississippi-Alabama Sea Grant because as she mentioned, flooding and coastal areas are kind of under threat constantly, being so close to the Gulf and the Atlantic or Pacific Ocean, depending on where you're staying. What we're working on right now in the civil engineering field broadly is trying to figure out with climate change and the increased frequency and intensity of tropical storms and flooding events, is trying to figure out how can we keep our coastal communities safe, how can we keep the recreational activities open, how can we make sure that everyone still can enjoy these things as these storm events are getting more and more wild and crazy. And one of these things that we've discovered is a feature called, or referred to as NNBFs, or natural and nature-based features. So as the name might suggest, nature is really good at, if you don't touch it, it works just fine. And there are these things called barrier islands, reefs, marshes, things like this that already exist in the natural environment that are actually really good at protecting our coastlines. Unfortunately, places like Gulf shores where you have a lot of beach recreation, those are kind of open to the forces of nature when it comes to storms. But Dauphin Island and the peninsula where Fort Morgan is are great examples of natural barriers that make Mobile Bay such a great natural harbor for shipping, but also protect the coastline within the bay area from those large wave actions. If you see here, the reason why we settled this area, and I don't know if you can see it here on the camera, the reason why this was such a great area to settle is because of that natural harbor that's created by the barrier islands. The awesome thing about that is it can get crazy out there in the Gulf with wave action and everything else with storms, but that natural barrier kind of creates like a ponding effect where you don't see as much erosion and those really bad forces that we want to knock back on. So I'm not an ecologist. I don't know how to build those kind of environments, but we are realizing more and more that as civil engineers, building seawalls, building riprap emplacements, that takes a lot of maintenance. You have to go back and inspect it. You have to rebuild it every time there's a storm event. But the cool thing about nature is you don't have to rebuild it. Sometimes dunes get knocked out and washed out, but a lot of times if you give it time, or if you build it up well enough on the first go around, it'll kind of rebuild itself, or there's very low maintenance involved with it. And we're trying to see, is there a way that we can justify the upfront cost of building out this ecological or in the environment so that we don't have to go back and rebuild these things after storm events. So our program is kind of in two waves. One, we're modeling the way that storms interact with our coastline. So we're seeing by direction and intensity of storms, where do we see a lot of flooding occurring in areas around the Mobile Bay area. Our focus is mostly in Mobile Bay, but we hope to expand it out to the greater Gulf Coast and Atlantic Coast. And then second, we want to see what's the impact of the community itself. So The obvious thing that you want to look at is property damage, roadway damage. If you're going to have to rebuild buildings or reopen roadways, there's a lot of cost involved with that. But also, what is the congestion that comes out of it? That's more of my field. I'm a transportation engineer. I like to see how we move our goods and our people, and what are we moving by water? Are we moving by road? Are we choosing to go by bus, car? Rail is becoming more and more popular in theory. Hopefully it grows a little bit more. But in Mobile Bay, we're really looking at how do those closures affect congestion on the roadways? Do we see an increase because there's more coastal roads that are knocked out? Is there more diverting traffic that has to move to the interstate? I-10 is a great example. The tunnel that goes under downtown Mobile, if that floods, that completely cuts off Daphne and Fairhope from being able to come to work in downtown Mobile. So seeing how those things interact. And the great thing is once you know the flooding that you can predict, you can say, oh, well, if we can predict when that's going to occur, we know how to move the traffic around that ahead of time and take those economic pushes. The other big two things that we're looking at is resident quality of life and visitors to the area.
Can I ask you for a quick clarification?
Sure.
So you said if we know when that's going to happen, are you talking about like periodic events, or are you talking about an expectation that sea level change is going to require, that at some point in the future, and we don't know which point we're talking unless we kind of project?
Sure. We're kind of looking more at just specific events, but sea level rise is a big inspiration for the grant itself. It's kind of one of those chicken and egg things. If we can do the bigger events like storms, then it will help us with the average sea level rise as it occurs. Basically, the way you model it, when a storm comes in, it's like a big bulge of water that's being pushed with it. Saw that a lot in Florida with Hurricane Ian. There were whole areas where it was super low tide, like entire bays are empty because the water's been pushed away to where other parts of the storm are going with it. Sea level rise is just going to see an average raise everywhere, but with those big storm events, you see that big surge of water. That's really what we're trying to model, is that huge movement, but the sea level rise in and of itself makes that bulge bigger. So kind of a chicken and egg situation where you're kind of doing the big stuff first and then you can look at the small stuff afterwards. But my work has been mostly looking at visitors and resident quality of life, so that getting around the after closures or the last time you experience a flooding event as visitors, what inspires people to come to the area. If certain aspects of the community are damaged or closed down, say the beach, restaurants, things like that, a lot of people won't come to visit the area. That's what attracts them a lot. So it's not just the upfront cost of repairing things, it's also all that lost income to the community that we're going to miss out on because people aren't coming to experience the natural beauty of Mobile Bay. So the hope with this project is that we're going to take those two things, the mapping and the economic side of it, and try to look at where are those little areas. When you create a map of the flooding, there's going to be little areas where it doesn't matter if it's a little bit of rain or a lot of rain, they always flood. They're always in these really bad areas where they're experiencing these events. And our hope is that we'll be able to justify the upfront cost of maybe instead of a seawall, you can just expand the marshes or expand these NMBFs, these natural or nature-based features, to help kind of alleviate the impact of storms without having to have that recurring maintenance cost down the road.
Well, and sometimes it's not just the storm surge, that wall of water, although there is a pulse of water. Sometimes we're talking about excess rain that causes coastal flooding, because Mobile is one of the rainiest places in the country. We're right on the north central Gulf of Mexico, and when you have that, these air masses coming off the Gulf, this warm, humid air masses, it drops a lot of rain in this area. And so a lot of times low-lying areas, roads, as Chris is talking specifically about roads, they get flooded from rain. Sometimes all that rain can be associated with tropical storms. So in the northern hemisphere, tropical cyclones, hurricanes, spin counterclockwise. And if you took a hurricane, they spin counterclockwise, the storm bands, and if you took a hurricane and you divided it into quadrants, so you cut it in half two ways, the quadrant that passes over you, your home, your community, your business, when it comes ashore, will kind of, there are different storm effects from different portions of the hurricane. So for example, in 2020, this area was hit by Hurricane Sally, and it came ashore east of us. So more over in Baldwin County and the Florida Panhandle. But that storm was spinning counterclockwise. So on the right front, the front would be like the part of the storm that's moving forward. So on the right front quadrant, the place where that right front quadrant comes ashore experiences storm surge. So they get that pulse of water coming from the Gulf. And so that would have been over in, you know, the Panhandle of Florida, a little east of us. But then those storms can be hundreds of miles wide. So you're still feeling effects from those storms, even, you know, some distance from that storm surge. So it's spinning counterclockwise. It spins, you know, then a little inland of that right front quadrant, they get hit with a lot of rain. So you get the storm surge, and then when the storm starts passing over land, it starts dropping all that water. So a hurricane you can think of as kind of like a heat engine. It is powered by heat. So it picks up warm water from the ocean. They're warm water storms, tropical storms. So they're powered by heat energy, and then they hold that heat energy in water. So they pick up this warm water as they pass over the oceans. Then when they start passing over land, the water starts falling out of the storms as rain, and then that's when they start to fall apart. So they start losing their heat energy as they lose their water. And so it starts raining, and then that storm is spiraling. That storm particularly, Sally, passed over Mobile Bay as it's spiraling counterclockwise. And as Chris was saying, a lot of the water from Mobile Bay receded. So I know people who live on Mobile Bay, and they observed that the water was receding from the bank, the normal banks of Mobile Bay. It's getting kind of picked up and pushed, and then it came from the north and hit the east end of Dauphin Island from the north. And we typically assign a category of storm based on wind speed, but other effects can be just as damaging. So the storm surge can be affected by other things besides wind speed. And then also one of the things that will affect how much damage a hurricane might inflict is how fast it's moving, so how quickly it moves out of an area. So this particular storm was moving very slowly. There were times when it was only moving about 2 miles per hour, where what you might see more typically would be closer to 15 miles per hour, just to give you an idea. So it kind of lingered right on top of us. The western eye wall of that storm lingered right on top of us for a long time, dropping a lot of water. And then with those winds, we actually lost a whole lot of trees on the east end of Dauphin Island to Hurricane Sally. So, a lot of different ways that tropical storms, if you're talking specifically about some of the flooding that can be caused by tropical storms, a lot of different ways that those tropical storms might cause coastal flooding besides just the storm surge. So kind of a complex thing to analyze there. And one of the things that it makes me think of, Chris, is in ecology we have this sort of new concept. It's not that new, but it's kind of people are newly becoming more aware of it, and we call it ecosystem services. So we refer to ecosystem services, and that would be like Chris was talking about, how the barrier island and that peninsula, these coastal barriers kind of provide protection for the mainland from some of the energy that comes off the Gulf. So that would be one example of an ecosystem service provided by a dune system, an intact dune system. Salt marshes will absorb a lot of water, so a lot of storm impact. And often there is an expanse of salt marsh on a coastline. Think of maybe Louisiana, where you'd have a bigger expanse of salt marsh, where there's not that much development. So, the storm might pass over that expanse of salt marsh and drop a lot of that water. And so the marsh provides this buffer between the Gulf and the development, human communities. And so, that might be considered an ecosystem service. And one of the ideas was assigning monetary value to the ecosystem services provided by, these natural areas, salt marsh, barrier islands, and natural also it's not clearly defined, but just conceptually, the intact dune system versus a dune system that has been developed and the dune plants are kind of scraped away by the development. We have more modern development kind of sets back behind the dune system and puts these walkways over the dunes to get down to the water and the beach. But it kind of makes me think in terms of kind of like the opposite of the ecosystem services idea of assigning a monetary value to the services that they're providing, because you were talking about almost like a justification for putting resources into these engineering solutions.
Sure.
So if you're thinking about like this is something that you anticipate happening in the future. So, and there's some level of uncertainty about what exactly is going to happen in the future. And so how do we come up with, assign some level of certainty to these maps, and what's going to happen with the water and what the potential is for the coastal flooding, and so how do we assign like a monetary risk in order to propose a justification for putting money into these engineering solutions?
Sure.
So is that part of the project,
Yeah,
or part of the effort, generally
so
speaking?
Part of the so the finished product is going to be an interactive map that you would use for state, federal, or local governments. And the cool thing that we want to add to that is, to your point, is that there's an existing these existing ecological systems. You can assign a value of how much money you're saving basically in the damages that don't occur, or even just runoff from construction sites or things like that, because marshes also act as a natural filter for open water bodies. But you're exactly right. What we would like to do, and this will probably be in about a year's worth of development, it's a lot of software that we need to put into it, but the cool part of this would be that we could take those out and run the simulation again and see, okay, in the scenario where storm, whatever size, whatever direction that you were talking about, that storm surge doesn't affect the community, but if we take those natural barriers out, it wrecks them, or maybe it doesn't affect them. But that's kind of the cool side of it too, is assigning what you were talking about, is that monetary value to it. What I was talking about more is like doing it in substitution for infrastructure projects, so where you don't have anything in place. Would you rather build, concrete and steel, or use something like you were saying? But it's a lot more upfront cost to build it, but you want to justify it on the back end of it. But the same thing too, it helps to justify why you shouldn't interfere with these systems that are already in place. Is developers could say, oh, well, we're going to make X amount of money for the community because of home sales or commercial space that we're bringing in, but the juxtaposition of that, would be to say, but all of those places are going to get wrecked the next time we have a storm come through, because we've torn up all this natural barriers that are there. So yeah, you're absolutely right. It's cool to see. Hopefully, in the end of the year, we're going to have this cool thing where you can say, what would happen if we put it in, and also what would happen if we took it out.
So it's interesting to me too how much we have advanced using computers in our ability to analyze data. So if you think, if you imagine 50, 70 years ago and how much our computer technology and capabilities have advanced since then, these numbers would have been run, endlessly by, people with paper and calculators. And now we just have Yeah.
Yes.
So we have so much ability to process numbers now. So this increased ability to process numbers. So, you know, we can introduce these, additional levels of complexity to our analyses. And so who would be, I know you mentioned, but let's kind of talk about that a little more, about who would be the end users of this product. So we're talking about, you said government, so maybe we're talking about for the purposes of zoning, like so whether the community, if there's like a city-owned piece of property and they're trying to decide what to do with it, like put in a development or turn it into a park or leave it in a natural state. So maybe for municipalities or you mentioned state government, but also maybe would you expect that maybe some developers might want to use these products?
I would certainly hope so. I think it'd be a really cool, that's one problem that we're seeing. And so my home community, like I mentioned, was in South Carolina. We're experiencing a situation where most of what we had originally was wetlands and marshes and natural swamps, and they're filling it back in and draining that in order to build new developments. And a big problem we're having now is the water that used to just drain into the swamps and the community wouldn't be flooded is now flooding because there's nowhere for it to go. So it'd be great to see that kind of application used by developers to see, all right, how, if we are going to build it, how can we do it where we're not impacting it that way, or we can leave it and kind of have a hybrid scenario.
So maybe for site selection, for appropriate development so that it's not causing impacts to neighbors. So there are also problems where somebody might have an existing business or their home and they don't have flooding problems, but then somebody comes along and develops a nearby parcel of land and they change the topography, the local topography, so that the drainage changes. And so then their neighbor is now having flooding problems that they didn't have when they made their, when they selected their property and built on it. So we might be able to use products like these to avoid that kind of problem too.
Absolutely.
And so another kind of field is, we call it GIS. And it's Geographic Information Systems. So if you imagine a map, and maybe maybe it's an entire state, or maybe it is a town or a city and nearby outlying areas, you could do different kinds of, you could digitally do different kinds of cover. So you could figure out the vegetation cover and you could map that. And so you could say this area is salt marsh, this area is swamp, this area is forested, this area does not have vegetated covering, there's a lot of pavement here. And then you could overlay that with other things like elevation or like land use. So this place is residential, this area is commercial. And so you can, if you imagine it, this would be done digitally, like on computers, but sometimes I think it's easier to imagine it visually. If you're imagining like the clear or, the colored overlay sheets, overhead sheets, so you just flip down whatever layers you want to look at on top of each other to kind of analyze what's going on with the land and what you might expect to see as far as the drainage goes and how that might affect different communities in different ways. So that would be part of that. That would be sort of an element of that. The mapping would kind of be used, in that kind of application too.
Absolutely, and also with that, obviously you want topography, you want ecology, but the societal stuff too. Like lower income areas are typically built in low-lying areas because the property values are lower. And understanding that those people are going to be more at risk for flooding, not just for the flood itself, but the recovery time on it. You need to understand how that all interacts with it. And it can that's what I was saying with some government applications would be understanding that people who can afford flood insurance, probably in higher income areas, might not need as much government assistance in the rebuilding process. It can be handled through private practice, and kind of understanding, well, we're going to kind of focus the public funding towards these areas that are already in more danger and will need that assistance on the back end of it. Or ideally you make it a situation where that doesn't happen, or you're putting in those controls where it'll lessen the impact of the storm or a flooding event.
So can you tell us a little bit more about your specific project, your work?
So I'm more on the sociological side of it right now. I'm doing a lot more surveys. I would encourage you guys, if you have time, I brought some paper surveys if you guys would like to fill one out, but we're trying to see more about the travel aspects of the missing out on visitors who are coming to see the area, but also the residential impacts. We're also mapping out average costs for repairs on buildings and roadway analysis. So in transportation, we love to look at how crucial areas, especially, so there's hierarchies of roads, arterials, which are like your big highways. Those are, if you think of it like in your body, there's the main arteries that run through your body. And then there's the little wings, or the collectors, which branch out to go to your neighborhood. And then there's local streets, which is where your house would be. Looking at those critical infrastructure areas and seeing how they interact and where they, if you have a crash or something like that, that's a typical transportation job in industry. What we're trying to do is add it to a flooding map. So what you were saying with the GIS stuff, we want to incorporate that more into it and see how it'll affect the movement of things, not just from getting to work in school or shopping, groceries, things like that, but also relief efforts. A lot of times we'll have problems where we have all the stuff we want to rebuild, but for great example would be if Dolphin Island's bridge is knocked out. Well, now we've got to get the logistics figured out of how to either airlift it or get boats in to bring in supplies to rebuild. So things like that is what we're kind of trying to map out. And then a separate student who's more in the fluid dynamic stuff, he's mapping out the flooding aspects of it. And again, putting that all together into one GIS program is the end result that we're hoping for.
I mean, it's kind of interesting to think about that as sort of a more acute event. So, you know, I have traditionally thought of these GIS products as a little bit longer term than an event that might only last, you know, a couple of days or a week. You know, we're talking about, like, again, like I mentioned, like vegetation cover and land use cover and water, like the streams and the rivers. But to look at this from the perspective of needing to have these maps for specific events, even if they do only last a day or so, we're talking about people being able to get to work and get home, you know, and so we do experience flooding on Dauphin Island. A lot of you spend time on Dauphin Island, but looking around, I see some of you are mostly here in the winter, and we don't experience that flooding as often in the winter. I don't know if any of you have ever experienced the streets of Dauphin Island being flooded. Anybody? But it's not that uncommon. I mean, a few times a year, we might have flooding on Dauphin Island, and everybody who lives or works here knows, you know, you might have an alternate route that you can take. I mean, this is not too uncommon, right at the three-way stop. The three-way stop on Dauphin Island, everybody knows that means the right at the water tower, where you are driving onto the island and you kind of hit the road that runs the length of Dauphin Island. Dauphin Island is a long, narrow barrier island with an east-west orientation. There's a road that runs east to west. And then some of the neighborhoods experience flooding. Sometimes we'll get flooding, especially if it coincides with a high tide, a really high tide, like right at the ferry, and there's no alternate route by car through there. So you know, to the Sea Lab, to and from the Sea Lab. So you know, those are some of the things that are interesting to think about. So would you be planning? So would they be more long-range plans? So we need to create infrastructure that's a permanent solution to that, or would you do things like having like temporary solutions for temporary, you know, these event type problems?
I think there's definitely applications where, I mean, obviously before you see flooding events, especially, I've heard a lot of people who are from like the Chicago area, the Mississippi River, they always bring out sandbags if they're expecting upstream a lot of water to come through, and you'll guard those areas where you know there's already going to be flooding and try to do those temporary protections. But I think the plan is that you don't want you want the temporary solutions to be able to be more permanent in the long run. That's a problem that we have a lot in disaster engineering, where You'll have washouts from, especially in like national parks. You'll see washouts in the bridges that go over rivers, and then they'll come in and they'll build, there's these prefab aluminum bridges. They'll build that to help get emergency crews in, and then they just kind of leave it there. Now, those are made to be there. The lifespan of those are supposed to be long-term, but that is the creep effect of some of these natural disaster things. Is we want to create solutions that can be permanent, but we want to have a plan for it to be permanent, not for a, well, we kind of forgot about it. And
Not
left it
reactionary,
there. Yeah,
exactly, but premeditated. Well, and just as an example of an older engineering solution that over time, you know, we've come to understand, we people have come to understand that, you know, it can create its own problems. And as Chris was explaining, often the natural state, you know, if we are working with that and around that instead of trying to work against it, we are better off. But for example, putting levees on the Mississippi River. So some of you might be aware of the levees that were built to prevent the Mississippi from, flooding the banks. But before those levees, without the levees, the flooding was more predictable, and it was sort of a more, maybe I could use the word gentle flooding event. And then with the levees, you end up having these periodic major floods where the river may, once in a while, overtop those levees, and it floods. And then it can't recede back into the Mississippi because of the levees. And then if, you might recall Hurricane Katrina. So that was a similar thing happened with Hurricane Katrina. So it overtopped the levees, and then the water stayed in place and didn't drain back out for a lot longer than it would have, in a more natural state.
Sure. Over-engineering the situation, or not thinking through the whole process of it, of what
or not initially understanding. So
Sure.
This idea of sort of incorporating that understanding of the value of these natural systems and trying to, work with the natural system instead of against it is an approach that we've learned from. I'll say mistakes. We might put it that way, just because we talk about learning from our mistakes, but learning from challenges that we've created for ourselves, that where we were engineering things, and then we gave ourselves some challenges to work through. Yep. with the engineering solutions that we had come up with. So Chris mentioned that he has some surveys, so he is collecting data for his research. And so he's got some of those surveys, if you would be so good as to fill those out for him. And if you are watching from home, we will add a link to his survey in the description. So Chris would be glad to have survey data to use in his research project. So if you would be willing to fill that out, just follow the link that we will add shortly after this stream is posted. And what would you say that you would like to kind of leave folks with as a main message of this project, of this large-scale effort, of this area of study?
Well, I would kind of a two-parter. One is that people like to think of engineers and ecologists that we're enemies, that we we wreck all the stuff that you guys want to protect. And I guess the overarching message should be that is changing. It might have been true years ago, but it is changing to where we want to work more together and have that interdisciplinary effect. Auburn University's Department of Civil Engineering is not just civil engineering, it is civil and environmental engineering. And we're trying to move in that direction where we already have these great things that exist in nature, and we should, like we were saying with the levees, don't over-engineer the problem, or don't ignore the fact that a lot of these systems exist in a way that they can help themselves if you just listen to what's already going on within nature. So.
Well, thank you so much for chatting with us this morning, for coming down. Chris drove down from Auburn this morning to chat with us. The C-Lab is a consortium of colleges and universities in the state of Alabama, and Auburn is part of our consortium, but Chris he's in the engineering department at Auburn, so we don't often get engineering students who come down to the C-Lab and chat with us. So it's nice to have you, Chris. Nice to have a different perspective, and thanks for coming down and chatting with us.
Thank you so much for having me.
So I will turn this off, and then maybe